Now, hello guys. Let us see how we can solve these questions and linear momentum, circular motion, which is rotational motion, rotational work, energy, and momentum, as well as equilibrium. Okay, so I have got a number of questions with me here, and I want you guys to pay attention as we are going to solve these questions. Okay. So in preparation for test 2, let us try to solve these questions which I just got them from different past papers. Okay, so this paper has got almost all the questions from Newton's laws of motion, work, energy and power, linear momentum, circular motion, um, rotation, work, energy and momentum, equilibrium, as well as mechanical properties of matter. So for you, if you are doing 1015, the only topics which can help is just three, which is Newton's laws of motion, static or work, energy and power, and linear momentum. Then the rest they are for 1010. So now let's begin our discussion with linear momentum part. Okay, but this paper has got almost all the questions, about 60 questions, comprises of all the topics I've mentioned, which can help you to revise for test 2. Okay, so the first question is saying, in a perfect elastic collision between two objects, their relative velocity after collision is. In a perfect elastic collision. So perfect elastic collision, we're talking about what happens after this formula. Okay, which is initial plus m2 v2 initial is equal to m1 v1 final plus m2 v2 final. So what happens, guys? One thing we should know is that under elastic collision, momentum is conserved. 2, kinetic energy is also conserved under elastic. So now if kinetic energy is conserved, meaning the velocity is going to be the same before and after. Okay, if kinetic energy is conserved, so meaning that we need to talk about the velocity now, because the answers are just talking about the velocity. The velocity has to be the same before and after collision. So let us check for that answer. So it's saying the first one is saying 0, no, less than their relative velocity before the collision, no, but we have said equal. So if I go to D saying equal to their relative speed before collision, so it has to be the same because kinetic energy is conserved. So in this case, D is the correct answer. Let us go to 3. 3 is saying an astronaut whose total mass is 100 kg eject 1.0 grams of gas from his propulsion pistol at a speed of 50 meters per second. His recoil velocity is. Now, I'm going to give you a scenario where you have got a gun. Okay, where you have got this is a gun. Now, what is happening is that as you are trying to, when the bullet is coming here, the gun is going to experience, you who is holding the gun, you experience what we call recoil velocity. So you move this side. So the gun will move this side. So this concept comes from Newton's third law of motion. For every action there is equal but in opposite reaction. Okay, so I need to have the mass of the gun. Now I'm going to say the bullet. The mass of the bullet times the velocity of the bullet should be equal to, now this gun, it is going in opposite direction to the bullet, so it's going to carry negative, so it will be negative the mass of the gun times the velocity of the gun. This is basically the same principle which is here. So I'm going to say an astronaut is going to act as the gun, then the gas is going to act as the bullet. It's basically the same thing, meaning that I'm talking about the mass of the bullet, meaning the mass of the gas, which is 1. So convert that to kgs, which is divided by 1000. You expect to have 0.001, 1 divided by 1000, 1 divided by 1000, 0.01. Yes. Then the velocity, we have been told that it was ejected at the velocity of 50. Okay. Then now here negative, the mass of the gun, which is the mass of the astronaut, which is a 1000 or 100. Then the velocity, I don't know, it's the one I want to find. So you say 0.001 times 50, I'm getting 0.05. Divide this by 100. Okay, so I'm getting my velocity of the gun to be equal to this negative. It just tells me that it was going in opposite direction. So you can say the magnitude of that velocity of the gun, which is the velocity of the gas in that case, it is 0.0005 meters per second. That's the answer. But in our answers here, they have put it in scientific notation. So if I can shift from here 1, 2, 3, 4, meaning it will be 5.0 times 10 raised to the power negative 4 meters per second. That's the basic idea. Any kind of recoil velocity, this is just the basic idea behind recoil velocity. So the correct answer here is B. Okay. Now let us go to question 4. Question 4 is saying an object that has momentum must also have. If an object has got momentum, meaning that that object is moving. Okay, an object is moving. If an object is moving, it has got momentum. So here is the object. This object is moving in this direction. It's going to have velocity at the same mass. So when an object is moving, we expect to have kinetic energy. So when an object has got momentum, meaning it's moving, it also needs to have kinetic energy. That's the answer. Okay. So I didn't put question 2 anyway, aside from 1, 3. Okay, it's fine. So we go to question 5. So question 5 is saying a man pushes a block up an incline at a constant speed. As the block moves up the incline, what is going to happen to potential energy and kinetic energy? Let's have our incline. This is my incline. The theta is there. When an object, when we have got constant speed, meaning that if the speed is just 2, it will not going to change. The kinetic energy I'm going to have at point A is going to be the same as point B. So we need to find the answer which is going to tell us that kinetic energy will be constant or will remain the same. What of potential energy? From point A to B, as you are going to point B, potential energy is increasing because H is now increasing. So potential energy is increasing. So we need to look for the answer which is going to tell us that potential energy is increasing but kinetic energy remains the same. A. Is kinetic energy and potential energy both increases? No. B. Is kinetic energy increases and potential energy remain the same? No, but the opposite. Is potential energy increases and kinetic energy decreases? No. So its potential energy increases and kinetic energy remains the same. So D is the correct answer. Let us go to question 6. In an elastic collision, what happens in elastic collision? Let me just explain something here. So we have got two types of collision. We have got what we call elastic collision and inelastic collision. So we have elastic collision and inelastic. So under elastic collision, kinetic energy and momentum, they are both conserved. But in elastic collision, only potential, only momentum is conserved. Kinetic energy is not conserved. So the question is, in elastic collision, what happens? Both kinetic energy and potential energy, or both kinetic energy and the momentum, they are conserved. That's the answer. Let us look for that answer. Neither no momentum and kinetic energy are both conserved. B is the correct answer. We go to question 7. So question 7 is saying, in a perfect elastic collision between two objects, their relative speed after collision is, this question is the same as question 1, where we said they are going to be the same. So we said they will be equal to their relative speed before collision. So for this one, we said A is the correct answer. Okay, so we can go to question 8. Okay, we go to question 8, but allow me to get rid of this. So an object has momentum must also have, again we talked about this question, so we said it is kinetic. Oh, an object that has got momentum must also have what? Kinetic energy. That's what we said. So let's go to question 9. A bullet hits and gets embedded in a solid block resting on a horizontal frictionless table. What is conserved? So when something is embedded, that is, you have this. So here is a bullet. After collision, it has been embedded. This is basically inelastic collision. I talked about inelastic collision few minutes ago. I said under inelastic collision, momentum is conserved, but kinetic energy is not conserved. Then under elastic collision, momentum and kinetic energy they are both conserved. So in this case, if something is embedded, then they're moving together. That is inelastic collision, where momentum only is conserved. So the correct answer here is momentum alone. What is conserved? Momentum alone. B is the correct answer. Let's go to question 10. In perfect elastic collision. So this question I repeated 3 times. It's the same thing, equal to their relative speed. We talked about this. So A was the correct answer. Let us go to question 11. So question 11 is saying an object at rest may have when an object is just resting. So that is potential energy. Potential energy is defined as the energy an object possesses due to position. So potential energy is going to be the energy which is going to have an object is going to have at rest. Question 12. The momentum of a particle of mass m is p. Its kinetic energy is, so here these are just basics. Kinetic energy is equal to half mv squared, but again momentum is equal to mass times v. So here let us make v as a subject of formula. I'll divide by m. So v will be equal to p over m. Where there is v here, let us replace p over m. So I'll have my kinetic energy to be equal to half m. Here I'll have p over m, but they have to be squared. So I'll end up having half m p squared divided by m squared. 1m can go and I'll remain with 1m. So half p squared over m, which when I do it properly is going to be p squared over 2m. So the answer is p squared over 2m. Here, when I was typing, I made a mistake. This b I was supposed to put 2m down. So the correct answer was supposed to be b. P squared. So when you find this question, the answer is p squared over 2m. Okay. That's question. Now we go to question 13. Let me first get rid of this. Question 13 is saying a block of mass 1 kg moving with a speed of 4 meters per second collides with another block of mass 2 kg initially at rest. After the collision, the lighter mass comes to rest. The loss in kinetic energy of the system is, so let's first find the formula. This is the elastic collision. The formula for elastic collision is this: m1, that is before collision, this is 2 now. Then you have got m1 v1 final, I'll just use prime, plus m2 v2 prime. So what happens now is since the first one is at rest, I'll cancel this. Then after collision, this was also at rest, meaning the only things I have is m1 v1 is equal to m2 v2 prime. So the issue here, guys, is this: we want to find the energy which was being lost. So we need first to find the kinetic energy initial and kinetic energy final. So to find the kinetic energy initial, we are going to use this information, okay, which is kinetic energy initial will be equal to half the mass v squared. What is the mass? The mass is 1, the v is 4 square. 4 squared is 16. 16 divided by 2 is 8. So the initial is 8 joules. After doing this, the final, now to find the final, I don't know the final velocity, so I need to find the final velocity. So here I would say the mass is 1, the velocity is 4. So here the mass is, okay, the mass is 2, the velocity I don't know. Divided by 2, you find that the velocity is now 2. So if I put 2 here, it's going to be half. The mass is 2, the velocity is also 2. Now I square it. 2 squared is 4. So 2 and 2 will go, and I'll remain with 4, the final. So you say the final, which is 4, minus the initial, which is 8. So you end up having negative 4 joules. So you just get the magnitude, which is 4 joules. So the answer is A, 4 joules for this one. Okay. Then another one is we are now going to question what? We are now going to question which question? That 14. So question 14 is talking about a bullet. Again, this question is basically the same as the question we were talking about that time. Question 14, we have talked about it, where we said only momentum is conserved. So let's go to question 15. So two balls at the same temperature collide. What is always conserved? We don't know which type of collision they are talking about. Okay? So the only thing you know that is conserved is momentum. You're not going to talk about kinetic energy because we don't know whether it is elastic or inelastic. Okay? So in this case, what is always conserved? Kinetic energy is conserved, or momentum is conserved for all types of collision. So the answer in this case is A, momentum. Then momentum is close related to impulse. So impulse is equal to the change in momentum. So it is close related to the impulse. The correct answer is A. Let us go to question 17. Question 17. Okay, question 17 is talking about, so the question is 800 kg is saying that 800 kg car moving at 800 kilometers per hour overtake and hits a 1200 kg car moving at 40 kilometers per hour in the same direction. If the two cars stick together after collision, the linkage has an initial speed of okay. So here it's just the same. This is now the linkage after collision, they are moving together, meaning it is inelastic. So in elastic collision, this is the formula you need to know. So after collision, they are moving together, so it will be m1, I'll add this, then time the velocity, which is the final, which you want to find. So the initial mass is 800, the velocity is 80, Then again here the mass is 1200, the velocity is 40. Okay, then the mass, like we have said, is 80 plus 1, or 800 plus 1200. The velocity I don't know. So if we add this, we do the math, we'll find that is 800 times 80. So 800 times 80, I'm getting 64,000 plus 1200 times 40, I'm getting 48,000. Then there I add 8,000 or 800 plus 1200, 2,000 times that. So divide both sides by 2,000, even here by 2,000. So you say 64,000 or 6,400 or 1,000, sorry, plus 48,000. The answer you find divided by 2,000. So I'm getting 56 kilometers per hour. I don't have to change them to meters per second because the answers are already in kilometers per hour. So the correct answer is B. Question 18. In any collision between two bodies, their need not to be conserved of. Now, in any, that they can mean elastic or inelastic. So meaning, angular momentum is always conserved when we talk about rotational work energy and momentum. Total energy is always conserved. Linear momentum is always conserved. But kinetic energy is not conserved in elastic collision, but is conserved in just elastic. So then we are going to say there is no need of conserved of what? Kinetic energy. So that's the answer. Now, 19 all the way to 70, we have got a lot of questions here. So I'm going to answer them. If you want to access all of them for preparation of test 2, like I've said, for all the topics, so for this one we've just talked about linear momentum, but for the rest of the topics I have the video and you can access it at only affordable price. Just get in touch with me using this number 0767 729927. Then you'll be able to access all of them and you are good to go for your test 2. Okay.